Okay guys, let's finish up 5.2. Let's go ahead and calculate number 4 in the last video. You borrow $10,000 in student loans at a 4.5% interest rate compounded monthly. How much will you pay back at the end of 4 years, and how much is interest? So the future value, using our formula, would be 10,000 times 1 plus 0.045 over 12 to the 12 times 10 power. That'll give you the total amount you end up paying at the end of 4 years, and then we'll find the interest by subtracting out how much you borrowed. So 1 plus 0.045 over 12, all to the 12 times 10 power, or 120th. So the total amount you end up paying back is $15,669.93. Which makes sense. 4.5% interest rate for 10 years. You would expect it to about 50% increase. And it did. So to subtract the $10,000 you borrowed off, that's $5,669.93 of interest. Oh, it's only 4 years. Okay, so let's pretend that we did it in 10 years. So if you keep your loans for 10 years, this is how much you borrow. If you do it for 4 years, it's 4 here instead. Because most people don't actually pay off their loans in 4 years, because you're usually just getting out of college in 4 years. But if you did it in 4 years and you want to calculate to make sure the answer will be up, I'll do the problem on the key. And I can tell you what it is here. In 4 years, it would just be $11,968.14. But what this really does underscore is how important it is to pay off your loans as fast as possible. The difference in holding your loan for an additional 6 years versus paying it off originally is almost $4,000 worth of interest on this loan. So that is incredibly important to make your payments, and why not making your payments really matters. Okay, let's talk about the last thing in 5.2, which is effective annual yield. So the effective annual yield is what a percentage behaves like when it's compounded a certain amount. And it's 1 plus r over n to the n minus 1. The reason for that is we don't care how much you borrow, because we're looking really just at the rate. And the t is always its effective annual, how often it happens in 1 year. So t is 1. Then we subtract 1 off because we want to know, we subtract the original amount. So the idea here is what this is going to tell us is what the percentage behaves like. And now the key to knowing if you're going to use this is when it says an account has a nominal rate of a certain amount of interest, find the effective yield rounded to the nearest hundredth of a percent, compounding semi-annually, quarterly, monthly, and daily. So semi-annually, quarterly, monthly, daily. So semi-annually, that's twice a year. So that we have the same rate each time. This is 1 plus 0.126 over 2 squared minus 1. So if you're going to round the decimal, round it to 4 places so that you can get still 2 decimal places on the percent when you're done. So here what we end up getting is 0.1300 when we round, which is 13%. So when you take a 12.6% interest rate and you compound it twice a year, which means that middle term gathers some value and that gets interest itself, it really behaves like a yearly rate of 13%. Now the rest of the formulas are exactly the same. Only it changes. Quarterly is now 4 into the 4th power. And the more often you compound, generally this should always go up. So it does reach like a limit of reasonableness. When you do it 4 times, it's 0.1321, which is a 13.21% interest rate. Monthly is now an n of 12. Now we think the jump from 2 to 4 is not as big as the jump from 4 to 12 in terms of number of times, but actually this is just 0.1335, 13.35%. Despite the fact that this increased 8 instead of 2, the percent actually increased more originally. So it looks like there's some level of what we call diminishing returns here. And lastly, daily, we'll use 365. You're like, this is a huge jump, right? From 12 to 365, so I'm expecting a huge jump in percentage. But in reality, this is 13.1343. It's an even smaller jump, despite going dramatically up. It didn't actually increase that much. And you could go from daily to hourly, so multiply by 24, and it would barely go up as well. Like, just for fun, we can do that. So see, what about hourly? Well, hourly means there's 365 times 24 hours in the day. So how many hours are there a year? 8,760. So let's see what happens when we do this. It's still 0.1343. So there's literally no difference here, and there may be like a 1/100th of a difference, depending on rounding, but there's very little difference here between daily and hourly, which suggests there's some level of diminishing returns on how much of a bonus you can get. And actually, that diminishing returns is where the number E comes from. So we'll delve a little bit more into E and what continuously compounding means, so you're constantly compounding. But this is all for 5.2.